Virtual LANs. Before the development of virtual LANs, local area networks were restricted by geographic boundaries. In other words, communities of interest, like a finance department, had to have each computer in a common physical area. Luckily for us, the development of VLANs shattered that mold and enabled those same communities of interest to be defined logically and without physical boundaries. In this nugget, we're going to start with a brief look at the history that demanded the creation of VLANs, followed by defining exactly what VLANs are and their associated benefits. And then we're going to look at a few design approaches for VLAN application and discuss the trunking as it's used to extend the switch backplane. And we're going to end up with a discussion on VTP, which is VLAN Trunking Protocol. So far, we've learned that switches have the ability to divide collision domains, and that routers have the ability to divide broadcast domains. So in this area here, I have a collision domain. Everywhere beyond this router interface, I have a broadcast domain, right? Switches also have the ability to support multiple connections over the backplane within these hosts. All right, so that's easy enough, pretty straightforward. And for early networks, that was enough. But let's say I had a case where I had these hosts, of which there are 11, and I needed to divide them by logical groupings or divide them into broadcast domains. Let's say I had to take 3 here, and then the 5 that remain. What are some of the reasons that I might need to do this? High broadcast traffic is what's going to force this action. Some of the protocols, if you will, that cause this problem would be like ARP, the Address Resolution Protocol, or DHCP, Dynamic Host Configuration Protocol, that use a lot of broadcast information to either discover addresses and names or to discover the IP address that will be assigned to that box. Also, you might have high broadcast using applications like X Windows, or if you're using Novell or NetWare, you might have a lot of SAPs on the wire. Because of these reasons, you need these divisions. So what do? We know so far that switches define collision domains and have nothing to do with broadcast domains, but the routers define the broadcast domains. So this might be one of the resultant solutions for our need here. We might have 2 extra switches that we had to purchase to divide the logical groupings that we created here across a router, 2 more interfaces on the router to connect to those switches. Although the solution delivers the desired effect, we broke up our broadcast domains here. It cost us quite a bit of money to add 2 new switches and add interfaces here. Beyond that, we introduced new points of failure into our network. Again, 2 interfaces and 2 switches that could cause problems for our end host. All the time, we had enough port density here to support all the hosts that we had on our network. We simply needed an ability to divide the broadcast domains. It's not that we really needed new hardware. And that's where our answer comes in, and the way we will implement this in the future is VLANs. The name VLANs stands for Virtual Local Area Networks. And remember that local area networks are loosely defined as a broadcast domain. So in other words, this division that is inherent to a router, this broadcast domain, can be called a local area network. So let's define exactly what a VLAN is. It's logically defined. This is where we get the virtual part in. Community of interest. Community of interest can be defined as a department like finance. It can be defined as a group that has the same application on their PCs that need to share information, things of that sort. And that limits a broadcast domain, which is our definition of a local area network, again, the loose definition. So that's where we get virtual LANs, okay? Now, as we see over here, these LANs are created in the software of the switch. So they're here because we have, represented by the blue, 1 local area network, or virtual LAN. In the red, we have the second, and in the green, we have the third. So that broadcast traffic from any of these 3 hosts will only be shared with the other host in that same logical area network, the virtual one that is indicated by the blue, and the same with the red. So you'll never have broadcast traffic from the red going over to the blue. And in fact, to get any traffic at all from a red host over to a blue host, you have to go through the router. So you have to travel through the switch, hit the router, and then come out of the router over to the blue VLAN. So simply said, we have to have inter VLAN traffic running through routers, okay? And then the software broadcast domains are maintained within the switches. The other thing that you need to be aware of, at layer 2, we rely on spanning tree protocol, as we discussed earlier, to keep our environment loop-free. Understand that every VLAN has its own instance of spanning tree protocol. So 1, 2, 3, 4 ports on this switch, make up one STP domain. Then in the red, 4 again. And in the green, we have 6 ports that make up an STP domain there. This diagram was created to illustrate the division between the broadcast domains with the number of hosts. In other words, these 3 here, and then 5 created here. But it is a bit misleading. So let's move into this diagram so I can tell you a little bit more detail about how these VLANs are operating. The first thing I want to make you aware of is that as far as the host, in this case we have N1, and here we have N2, VLAN membership, or anything to do with VLANs, is totally transparent to them. They have no idea that VLANs exist on the network or even within the switch. This is how it operates. When N1 creates a data unit to be sent over this wire, it looks like this. Okay, it's all packaged, and this is the original data unit. Once it gets into the switch, this is where there's some VLAN awareness. Remember, we defined this as software-based local area networks. So there has to be the software in the switch to understand the divisions, okay? At this point, it's the only device that is aware that of the ports it has defined on it, only some are in the same local area network virtually, okay? So as soon as switch number 1 here receives the packet on this port, it says, you know what, I've designated that as a member of, for the sake of our discussion, the blue VLAN, right? So I'm only going to allow packets that come in on the blue VLAN to go out on the blue VLAN, okay? So it will not transmit the packets out of these other 4 ports because they are members of a different VLAN. It will go out N2 and it'll receive the packet. Now, while it's in this backbone, you can almost look at it as the original packet with a header here identifying which VLAN it's in. Now, this is commonly referred to as frame tagging. And it's just a method used to identify that a packet belongs to a certain VLAN. So coming from a certain host into the switch fabric, it belongs to that VLAN. Now, this frame tagging that we're talking about doesn't actually happen when you have one switch working alone to separate VLANs, because the software in this switch, the brains, if you will, in this switch back here, knows exactly which ports are involved in each VLAN and simply forwards them across. It's at the point to where we have multiple switches in an environment and they need to share packets between themselves destined for other VLANs, that this tagging or this actual header is going to be added onto the frame so that you can essentially extend the backplane of this switch over to the backplane of this switch. It's a way of them communicating VLAN information. But for now, simply logically, this is happening, or in the brains of the switch, when you have one switch involved. We're going to study this backplane extension in more detail later in this night, but for right now, let's talk about VLAN membership. There are 2 ways of becoming a member of a specific VLAN for these ports, and the first is static membership. Simply put, what you're doing there is you are defining membership based on ports. You would come up to this port and identify it as a member of the blue VLAN. Now, this is regardless of what is connected out here. In this instance, we have N1 as a host connected to this port. Right now, it's a member of the blue VLAN. If for some reason something happened to N1 and you had to move it to another part of the network, and now you had a new PC in here supporting a new user that is N3, that is still a member of the blue VLAN. Regardless of what host is out here, this is going to be blue, no matter what. Another method of VLAN membership is dynamic. Now, this is going to be defined by a couple of parameters that are available to it. First is the MAC address, which exists at layer 2, so it's something that will change when you're moving from N1 to N3 or to any other host for that matter. Another is protocol type. This is a field within the layer 2 header that defines what kind of protocol is coming in the upper layers. Now remember, we have to deal with layer 2, so that's 2 of the options we have in those headers for defining what member of, or which VLAN this port will be a member of. So, using our example, we have N3 here now. When it connects, this switch is going to consult with what is called a VLAN membership server. And it's going to go out to that database and say, okay, I have, let's use MAC address. I have a specific MAC address coming in here. Look up that MAC address and tell me what VLAN it should be a member of. The return is, okay, blue. So it's blue. Now, at an instance that something happens to N3, we move it to another part of the network, and we now bring in N8. That MAC address comes into this port. You go over to the database server, and it says, okay, that MAC address now belongs to a green VLAN. This switch, or this switch port, is going to change to green as a VLAN identifier as it was blue with N3. So that's dynamic versus static configuration or membership of VLANs. Now let's take a look at the commands involved in creating VLANs and assigning specific ports to that VLAN. Recall from earlier nuggets that we talked about two ways of configuring switches. One was a menu-driven interface, and another was CLI, which was the command line interpreter. This is an example of the CLI. It's iOS-like. Remember, it's not going to be exactly like the iOSs that you're familiar with in a switch, obviously, because we're configuring different devices, okay? But here we go. This is what it would take to create a VLAN and assign that VLAN to a specific, what we're going to term a port here is going to be termed on this iOS as an interface. So let's see this happen. First, we're going to get into the configure mode via config T. Then we're going to type in VLAN as you see it here. Type a VLAN number ranging from 1 through 1001, and then we're going to type in the type. In other words, Ethernet, FDDI, ATM, which would be an ELAN, things of that sort. So as far as our examples, we're always going to opt for the Ethernet as the type. So VLAN number could be 2, type Ethernet, hit enter. Then you type in VLAN as you see it here. The VLAN number, again, that could be 2. Type in name, the word you see there, and a name associated with that VLAN. Now, because we are defining communities of interest, and they can be defined by department. Let's say like personnel, the name could be personnel. Or they can be defined by application. You could write the name of the application that all of them are accessing here as part of the name. It's something intuitive to let you know what this VLAN is meant to logically divide. And then the state. The two options with the state are operational or suspended. Obviously, as you can probably tell, operational, everything's going to work as normal. The VLAN is turned on. Suspended means the VLAN is turned off. We're not passing VLAN traffic through this interface. All right, at that point, we need to get into the interface configuration mode by typing in interface, a type, which we said earlier we're going to stick to Ethernet, and then the mod number, the module number, and the port. Now, when we're looking at a 1900 switch, let's say, which we've already defined as being a 1U box with ports across the box, you wonder why mod number? Well, that mod number is always going to be 0 because there's only one module and it's module 0. This is only 1U thick. And then the port number will be the port counting from the left over to the right. And unlike what we normally see with Cisco, they don't start with 0. It actually on the switches starts with 1 through, if it's a 1912, 12 ports. If it's a 1924, 1 through 24 ports, okay? But the distinction there is they don't actually start counting with 0 as you would normally see in a Cisco device. So if I wanted to configure port 11 on this device, it'd be interface Ethernet 0/11, okay? Then we got to get into the VLAN membership. Note that our config here has changed. Now I'm config IF, so I'm configuring an interface. VLAN membership, you type in exactly as you see here, and there are two options, as we discussed up at the top here. I love it when all this comes together, static or dynamic. Now, if it's static, you're going to simply opt for a VLAN number. If it's dynamic, that'll be the end of this command, and the VLAN number will not be an option, because from that point on, you have to define with other commands a VLAN membership server that this switch is going to talk to look up to the database. Kind of what we set up here at the top. All right, and then once you're done with that, you can use the show commands to verify what you've just done. Show VLAN membership will list every port along this 1912 or 24, and then it will give the associated VLAN that's assigned to it. Or you can do show VLAN as you see it here, and then type in a VLAN number. Let's say you opt for number 2, and it's simply going to show you information for that one VLAN. No sense in just talking about it. Let's see it happen. This is the intro, if you will, into a 1900. As soon as it comes up, it identifies itself as a Catalyst 1900, the management console. And in here, very important, it gives you the type of software. The Enterprise Edition software is what we're dealing with on this particular 1900. Keep in mind that there are different levels of software. In fact, the standard version or standard edition of software is going to give you a different look and feel in this area here. And the reason for that is, remember, we talked about switches having a couple of ways to configure them, either menu-driven or command line. Well, with the Enterprise Edition, you get both. Okay? Now, with the Standard Edition, you would not have the command line interpreter as an option. Okay? Then you also see here IP configuration. This is only going to be available in this particular menu as long as the IP address has not been configured on this switch. So you ask, why IP address on a switch? This is just a management IP address. When you assign this so that you can telnet over to the switch or get there via the web-based interface that is available for configuration as well. So remember, if you see this here, it means that the IP address has not been configured for this particular switch. For now, we're going to configure the VLANs with the command line interface. All right, because that's what we talked about here with this whiteboard. So let's go ahead and opt for K, which gives us command line interface. Immediately you see yourself here in the user level, okay, or the user mode. We need to get into privilege mode as we would in a regular iOS device. Type in enable, and now we're there. We're in the privilege mode, which gives us access into the configuration. So we would type config T for configure from terminal, and now we're able to go ahead and manipulate the configuration of this device. The first thing we're going to do, as we stated here, is type in VLAN and then the VLAN number. So VLAN space 2 space the type. So this is going to be Ethernet. Hit enter. All right, now that that has been defined, we need to do a little more as far as configuring that VLAN or tailoring it to our needs. So the second line there is VLAN, again number 2, and we're going to assign a name to that. Let's start with finance. No, let's start with personnel. And let's spell it right. All right, personnel is going to be the name, and then we've got to define the state, because by default, the state is going to be suspended. So let's go with operational, and then hit enter. Now we have our VLAN configured, but it isn't applied to any interface. This is where it's somewhat like an access list. You can have access lists configured on your device, but they don't do anything. They don't affect traffic until they are assigned to an interface, right? Well, in this case, until they are assigned to an interface on the switch or a port, these VLANs don't take effect either. So the next thing we need to do, as we've identified here, is get into the interface configuration. So let's do that with interface, E for Ethernet. Again, the mod is going to be 0 and it's 1900 because it's only 1 U thick. 11 is going to be the specific port that we want to identify and configure. Now we go into VLAN membership, and we can use our shortened commands for this, VLAN mem, identify static or dynamic. We've talked about both, but in this case, let's go ahead and define a static, and then we need to assign a VLAN number. Well, we just created VLAN 2, so we know it's in existence, and it is in existence for personnel. Let's say that the device that's going to be connected to this particular port is a personnel computer, then we would assign this to VLAN number 2. Okay? Then we can get out of this configuration mode. Remember I told you that this is very much iOS-like, and what I mean by that is when you're dealing with the routers, there's a couple of differences between the iOS you will see there and what you're going to see on these switches. I'm going to hit Control-Z now, as it says right here. We can end with Control-Z. As I do that, you hear the click in the background and there's no effect. What you have to do is, if you're in a sub-command level, like we are here with config.if, you cannot Control-Z out of this configuration. You have to exit out of that subcommand level. Now when you're in the global level, you can Control-Z. All right, just a little nuance, if you will, that you need to be aware of when you're dealing with this. At that time, now let's do our show VLAN membership and then our showing of the specific VLAN number to verify that the changes we made took place. So, show VLAN dash mem. And here we have a list. Let me make this a little larger. Of every port associated with this 1900, it's the 1912, so there are 12 10BASE-T ports, an AUI on the back, and then 2 fast Ethernet ports that are available for trunking. And we see here that by default, every one of these ports is assigned to VLAN number 1, except this port that we've just assigned to VLAN number 2. So that's very important to understand as well. Whenever you set up the switch, just by default, VLAN number 1 is assigned on every one of the other ports. So if you come in here and assign port 11 to VLAN 1 thinking you will be alone, you're not, okay? So make sure it's 2 and above when you're doing that. So there we have an example of the commands that are involved in setting up a VLAN and in assigning a specific port to that VLAN. You can see that it's not that involved. In other words, there are not that many commands that we need to issue to make this happen, but you do have to be aware of the syntax of those commands. And for many people, that's too bothersome, and they would opt for the menu-driven type of configuration rather than the CLI. What we can do from here when we're in the CLI is simply type in menu, and we're automatically over to our menu-driven type of configuration. They do that so that you can ease between the two environments, because it might not be that you're all for one camp or all for the other. You might not be completely comfortable with the fast access that you're going to find in the menu-driven type of command. You may want some of the advanced commands offered in the CLI, or you may just like the syntax within a particular environment. For that, you can switch back and forth. If you see here under option K, it will take you back to the command line. So if I hit K here, I'm back to the command line. Then again, if I hit menu, I'm back into the menu. Okay, so you can switch back and forth. Let's see now how much faster or easier it would be to set up a VLAN from the menu-driven types of commands. We see here that virtual LANs, the option we need is V. So all you have to do is enter V there, and it automatically takes you into that area. Within the VLANs, you want to list, add, delete, or modify. These first four options have to do with VLAN creation, deletion, and modification. Then we have VLAN membership, the E option here, that is going to allow us to set a port to a specific VLAN. So let's start by adding a VLAN. Option A, let's get into this mode, option A, and what we're going to have is defining the type is going to be the first question you ask, just as it was here. We had the VLAN number, and the type. So we're going to authorize type of Ethernet at this point. That's all we're going to deal with in our configurations here. We have a VLAN number, and it tells you VLAN number 3. This VLAN has not been created yet. What it's doing is it's saying the next available VLAN number in sequence that has not been configured as of yet is 3. Because remember, VLAN 1 was set by default. We set up VLAN 2 within our CLI command. So now it's saying VLAN 3 is available. Do you want to configure it? So we'll opt for that. And let's change the VLAN name by opting for the V option. And here it tells us that we can go as high as 32 characters as a max. Okay? So what we're going to do here, we define personnel under VLAN 2. We're going to define finance here. You can see that our communities of interest for the examples that we're setting up are defined by departments. Okay? Then we have the option of 802.10, the SED, which is the security identifier under FDDI. We don't need to set that as of yet. We'll leave it at its default of 100,003. Okay, the MTU size, let's leave it 1500. That'll work. We're not going to configure translational bridging, but we do need to look at the VLAN state. It's already enabled, but I do want to go in here just to show you how you change that. Okay, so the option I'm going to configure now is T. And it tells us here that we have two options, enabled or suspended. That's easy enough, but you have to read the line above. Configuration change only takes effect when the VLAN save command is executed. In other words, if I wanted to suspend this particular VLAN, I could hit S here, I suspend that, hit enter, and then I might make the common mistake of going to X to cancel and exit and go out of this configuration menu. Pay particular attention to cancel. We need to save and exit first. I don't want to save it as suspended though, so let me go back into T, change this to enabled, enter, and then save and exit so that this VLAN, its state, is operational. All right? We verify our work with the L option here, which lists the existing VLAN. So let me do that now, and then it's going to ask you, do you want 1, 2, it shows you how to do a range, or all VLAN information. We're going to opt for all, hit enter, and here we have it. The VLANs that have been created so far, number 1 was the default, 2 was personnel, 3 was finance, and then what we're going to see here is the defaults for FDDI, token ring, FDDI net, and token ring net. These are going to exist in the switch as soon as we bring it up. Okay, so the ones we've created are number 2 and number 3. Let's go forward with creating one more logical group or community of interest. This is going to be the R&D department. So I hit any key as it says. Get back into my configuration. Let's add a VLAN. All right, we're going to add number 4. Oh, I'm sorry, the type is number 1. We're going to add VLAN number 4, which is here, and we're going to change the name, and we're going to set this to R&D, which is research and development. Hit enter there, and the state is already enabled. So let's go ahead and save and exit just to be safe. I always like to save as many times as I can, and then we're going to list the existing VLANs. Again, we're going to opt for all. And there you have it. We have personnel, finance, R&D, VLANs 2, 3, and 4. So far in this nugget, we've talked about the history of VLANs, and we've also talked about the definition of a VLAN, a detailed look at the definition. Now we're going to talk about the benefits of a VLAN. They can be put into three categories, essentially. One is reduced cost, another is improved performance, and an increased security. So let's go over how these are affected. All right, the greater segmentation that is allowed without the cost of new equipment is the reduced cost. In other words, remember when we had our router here, one switch affecting many devices. When we wanted to break up these broadcast domains, it resulted in two more switches being purchased and two more router interfaces to make that connection. That was the cost savings here in allowing that logical segmentation of these broadcast domains. The other thing is simplified administration. In other words, the man hours that are associated with configuring these routers and the interfaces involved, as well as the three switches that we would now have if it wasn't for the existence of VLANs. And the points of failure. There's administrative man hours involved in troubleshooting more than one switch when we could have been troubleshooting one switch with many VLANs on it, okay? So cost savings here is man hours and equipment. All right, improved performance. What we're talking about here is that communities of interest now don't have to be hindered by geographical boundaries. In other words, if I have a network that has multiple floors, let's define it here, 1, 2, 3 floors, I do not have to have all of my people within one department, let's say personnel, sitting on one floor, finance sitting on another, R&D sitting on another. In fact, they can be mixed around. Because we run out of office space, have new people coming in, old people going out, things of that sort, this becomes cumbersome to keep them all in one physical area. And the other thing is, remember, and we're going to touch on this better in design, we don't have to define these communities of interest by the department. Maybe we'll talk about applications, like application X, application Y, and application Z. And the people who use that application can be spread across the floors in this manner. That cannot happen without the existence of VLANs. But with VLANs, we can have switches on each floor keeping track of which hosts are members of each VLAN so that we can have a VLAN going across multiple switches. And we're going to study that more as we look at the expansion of the backplane. But we see improved performance because we're no longer hindered by geographic boundaries as we define these communities of interest. We also restrict overhead traffic. In other words, if I have a router here and I have a switch that is going to have connectivity to all of these devices. One device sends out a broadcast. Without VLANs, every other device on this switch is going to receive that broadcast. Take the CPU time to acknowledge and receive that broadcast, and it might even not even require that they do that. Okay? So what we do is we go ahead and define these broadcast domains. So now this broadcast only affects two other hosts. Okay, so we talked about that earlier. Again, that will improve performance. And the last category is increased security. What we're looking at here, if you have a switch, a common use is a protocol analyzer on the monitor port to go ahead and monitor everything that is traversing this switch. Now, that's everything within a common broadcast domain. As I break these out into smaller broadcast domains, now my monitored port can only watch this broadcast domain versus the entire switch. Now, this is obviously inherently worse when we're using hubs, but it does allow for some better security within the switched environment. And then also there are some exploits that depend on broadcast traffic, or even multicast traffic for that point, that will be blocked from attacking all ports, just a subset of ports, by the division of these logical broadcast domains. Possibly one of the best benefits associated with VLANs is the flexibility in the design. It is only limited by your imagination. I'm going to give you 3 instances of common breaking points, if you will, in the design, but you can use anything that applies to your network. Okay, so here we go. Personnel, finance, and R&D. These are 3 departments. So in this case, I am going to divide my virtual local area networks by department, and you can see that here. Let's say that the blue is personnel, the red is finance, and the green is R&D. They can exist on multiple floors of the same building, or they can all be on the same floor, but I just wanted to show you that they can go across floors as well. Then we can also have it defined by project. Now projects can be defined as development teams. Sometimes you'll have a development team put together on a temporary or a permanent basis to bring out a new product for the company. Well, in the time that that's set up, you can have Project X as blue, Project Y as red, Project Green, or I'm sorry, Project Z as green. Okay, another one is based on application. It might be that certain servers, as we see here, server here has X application. This server has the Y application. Users of those specific applications want to be aligned with that server or in the same local area network. You can make that happen here with the different color codes of the VLANs. Now there might be, as in the case with the green VLAN, that we have an application that isn't resident on a server. It's resident on the host. This is a peer-to-peer type of application. So we will logically define them within the same group so that they can all use the same application together. As we end our discussion on benefits and design, you may have been thinking, all right, I see how you save on the creation or the cost of the other two switches that you would have had to buy to create this segmentation if we didn't have VLANs. But I don't see the cost savings in the interfaces. And that's a very astute observation, and this is why. If we go back to our switch and we go into VLAN configuration with the V, this is from the main menu, and then opt for E, which is VLAN membership, we see that every port that we have is assigned, let me go down a little further so you can see the headings, every port that we have is assigned to exactly one VLAN, okay, not multiple VLANs. And because of that, we were only able to support within our diagrams one VLAN per port. With that hindrance, that means that to support 1, 2, 3 different logical local area networks out here, I have to have 3 ports leaving this switch going to the router. Now we're aware that the router has the ability to sub-interface, so it can deal with these 3 different local area networks on one interface. It has no problem with that. Our hindrance is here in the switch. I can only assign 1 VLAN per port. So if I want to carry the VLAN information for the blue VLAN back to the router, I have to have 1 individual port, the red one on an individual port, and the green, okay? So we don't enjoy a cost savings here yet on the interfaces. All right, we said yet. This is what we move into now. It's called trunking. Really, it's the ability to have 1 port leaving the switch with all 3 VLANs, in the case of our example, many VLANs in your network scenarios possibly, intermingled on that 1 cable out of that 1 port into 1 interface on the router, so we truly enjoy the cost savings of the interfaces and the networked equipment. So what we've accomplished is analogous to having a single lane road here, support for single lane roads, and bringing that into support for a highway that will support multi-lane traffic across that 1 connection, okay? And what that's going to enable us to do, obviously, is cost savings. All right, now let's illustrate this. I have a host here that is a member of the blue VLAN. Again, remember transparency. This host is unaware that it is a member. I simply draw this line in blue for ease of configuration or ease of the diagram on our mentality. But here we go. This frame or data unit that's coming out of that host is the original data unit. Once it hits the switch and this logic has an awareness of VLANs, when it transmits that data unit out, it's going to have the original data unit with a header from the blue VLAN. All right, the destination, it's you know where it's coming from, is the red VLAN. Okay, so once it gets to the router, it's going to say, okay, I received this from blue. Now I need to send it out to red. I'm going to have the original data unit as I had here, and this time with a header assigning it to the red VLAN. It's going to go back through the switch and process out only the ports that are identified as members of that red VLAN. Again, the transparency exists outside of this switch. So when that data unit is transmitted to these hosts, it's going to be just the original frame or data unit that we had here. Okay? Be aware of what we're illustrating here, because we talked about it earlier in this nugget. It's the extension of this backplane knowledge extending out over the wire to another device. And this extension of the backplane knowledge we termed earlier as frame tagging. Now keep in mind that frame tagging is a process, okay? But there are different methods of achieving that process. What I've illustrated here with the encapsulation of having a header and specifically a CRC encapsulating the original frame, that is known as the method of ISL, inter switch link frame tagging, okay? There are other methods that exist, and in fact, 802.1q is another method of frame tagging, and simply put, that identification of VLANs is put within the original frame, so it exists here. So it doesn't have to have the header and the trailer. Now, both of these are probably beyond the scope of the CCNA. I just mentioned it here so that you have an understanding in your reading if it differs from the encapsulation that I had shown in the diagram. The configuring of trunks can be done via command line interpreter or the menu-driven configuration. We're going to show or illustrate the menu-driven configuration because it's much faster. So for basic setup, it's the desired configuration tool. All right, what we have here is the main menu for configuration. The first thing we're going to do is opt to configure the virtual LAN as identified right here. So let's go with option V. Once we're in there, we're wanting to get into the trunk configuration. So as we see here, T. Once we're in there, it's going to ask us A or B. Recall, the front side of our 1900 switches are going to have a series of ports, and those ports can either number 12 or 24 across the front face. On the end, you're going to have two more ports available, and they're going to be labeled A and B. These are your fast Ethernet uplink ports or trunk ports. These are available for, again, your multi-lane highway communication from switch to router or between one switch to another switch to carry multiple VLANs across. Okay, so that's why the only options we get are A or B on this particular device. All right, so we select there. I'm going to select A, hit enter, and it's going to give us information concerning that particular trunk. Okay, it's going to let us know, most importantly here, that the trunk is off. So trunking action is off, and we need to turn it on. So how do we do that? Looking at our configuration, we opt for on, off, desirable, auto, or no negotiate with the T option, and we see the T option here for trunking. So let's do that. All right, it's going to give a brief description of what each of these are. Let me tell you just quickly, on dictates that the port is always going to be a trunk. Off, it's always going to be off. Desirable, this is used to indicate the desire for the port to become a trunk. Okay, but the device will initiate negotiation if necessary, okay, which is going to be different than the auto. This is the same thing. It's capable and willing to become a trunk, but it's not going to initiate. So in other words, if you have one switch set to auto, the other switch will either have to be desirable or on in order for trunking to take place between the two switches on those ports that are connected together. And then no negotiate. It's always going to be a port, a trunk port, just like it is on option 1. The difference here is that it's not going to engage. In other words, it won't generate in dynamic ISL frames, either receiving or sending. Okay, so easy enough. Right now we're going to turn this in the on position. We do that by selecting option 1. All right, once that's there, you hit enter, and now you see the different state. Trunking is now turned on for trunk port A. Now let's take a more detailed look at the effects of trunking. What I'm going to have is an environment with two hosts, N1 and N2, connected to switch number 1, each with a different VLAN. VLAN blue here, VLAN red here. Trunking exists between switch number 1 and switch number 2. Then I have a host off of switch number 2, N3, that exists on the blue VLAN, okay? So as communication starts, I have the original data unit or frame. Has the destination MAC address, the source MAC address, the type field, the data, which is variable. In other words, all the information above layer 2, because this is a layer 2 data unit, in layer 1 once it's transmitted out, and then a CRC, which is cyclic redundancy check, simply make sure that this information has not been tampered with in transit, okay? It's a checksum. All right, once I get into the trunking portion here, when it leaves switch number 1, I'm going to have to identify the VLAN it's associated with. Two ways to do that, and we mentioned this earlier. The first is 802.1q. This is an IEEE standard, which means that it's standard across vendors, okay? The other is ISL, interswitch length, which is proprietary to Cisco. Now the difference is that ISL is an encapsulation. In other words, the original frame is inside two portions that have to do with the ISL encapsulation. Now with 802.1q, its tagging takes place inside the original frame, okay? So it's less overhead associated with the frame. Both have their advantages and disadvantages, and it will be up to you and your network to decide which one you want to use. The point we're trying to make here is once the switch 2 receives this data unit, either way that is tagged and identifies it as destined for a blue VLAN, then it's going to send a data unit out of switch 2 over to N3. And that's going to be the original data unit that we received from either N1 or N2. While this is the most common design for VLAN trunking, trunking existing between one switch and another switch, or a switch and a router, Cisco also partnered with Intel to create a network interface card for a server that is aware of ISL. Let me show you what I'm talking about. So you can extend this trunking, or the extension of the backplane, not only between switches, but also from a switch to a server, as we see here. N3 is a server operating with a specialized NIC, so that when N1 transmits data, you will see the original data unit. Once it leaves switch number 1, it will have the ISL encapsulation, which is the header and the CRC. When it leaves switch 2 on the way to N3, that same ISL encapsulation is in existence. That way, when the frame or the data unit arrives here, these two portions are stripped off, and what you're left with is the original data unit. Pretty cool stuff, huh? All right. Moving on to the last section of this nugget, we're going to discuss VTP, which stands for VLAN Trunking Protocol. Let me give you an analogy. Let's say that you're in the middle of a city, okay, with a blue car here. And what you're told is, without having a map of the city, find all the hardware stores that are existent in this city. Pretty hard to do, right? I mean, they could even be around the corner from you, and in fact, some could be pretty far off in that map. What makes this easier is if you're provided a map, and that map contains each of these hardware stores and their destination. Maybe not directions how to get there as much as where they reside, okay? That is what VTP will do for you. As you have a frame arriving here on switch number 1 in this port, this map will tell you that the blue VLAN exists out switch number 3, and this is how we get to it. Okay, so it makes the impossible quite possible. What's the requirement of VTP? You have to have a common domain. So each of these servers has to exist on the same domain. And you establish VTP domains with a simple command, and you just give it any name that you would like. So let's say our name here would be CBT Nuggets. Okay, once you establish a common domain, then you have to have one VTP server. That means one switch has to act as the VTP server. You have to have one master switch, okay? Then all the other switches can be a mix of VTP clients or VTP transparent mode. Clients means it's going to accept the information of VTP and transfer or forward that information as well. Transparent mode means it's not going to participate in VTP. It's going to be a standalone switch. We're going to configure VTP using our menu-driven options. Again, we go into the VLAN configuration because VTP is a subset or a sub-configuration of VLANs. Here we see the options. You can establish a domain name for VTP, and you can also establish the VTP mode control. Let's start with the domain name. So I'm going to go for option N. And what that does is it tells me that I can have a domain name up to 32 characters long. As we said, we're going to use CBT Nuggets. So I simply hit enter here to keep the current domain name, and we see it here. Domain name is CBT Nuggets. Then we have VTP mode control. This is where we're talking about the difference between the server, clients, or transparent mode. So let's go into option V. And here it explains the differences, and it also allows you to make the choice. So I'm going to have one switch as a VTP server, and the rest will be a mix of clients and transparent mode devices. So in this case, I'm going to opt for the server, which is indicated by the S, and then we'll hit enter. All right, and then I'm ready to go, at least with the first switch in my domain. I have the domain name CBT Nuggets, the mode control, I have my server assigned. Think of the headaches and the time that you're going to save by enabling VTP on large-scale networks over a manual configuration. It's going to be great. All right, we went in this nugget, we looked at the history, what demanded the creation of VLANs, and it was the fact that our logical groupings were hindered by physical definitions. Then we looked at the definition of a VLAN, understanding that it was logically defined communities of interest within one broadcast domain. The benefits were cost, improved design, and improved performance, and also security issues. Design, we looked at the fact that we could design our VLANs based on departments, applications, or even projects if we wanted to. Trunking was an extension of the VLAN backbone on the switches, between switches or even from a switch to a router, and we also saw that you can run it, the extension of the VLAN backbone, from a switch to a server. All right, and we ended up with a discussion on VLAN trunking protocol and how to make our life easier on large-scale environments when we're trying to pass information from one switch to another about what VLANs are supported on each switch. I hope this has been informative for you, and I'd like to thank you for viewing.